Arts Western Switzerland, specializing in spatial data, science, spatial statistics, GeoAI, volunteer geographic information BGI, and citizen science. Her work has contributed to the development of geospatial applications and the statistical analysis of geospatial data, utilizing free and open source software. Since 2017, Dr. Loftian has primarily focused on citizen science projects, particularly exploring the impact of technological advancements, such as artificial intelligence, and on these initiatives. Her research emphasizes how these technologies can enhance data validation processes and sustain user participation. Her work is especially concentrated on citizen science focused on environmental monitoring, where she investigates the role of species distribution, modeling and validating observations contributed by citizens. To that end, she has made several scientific contributions to the field of citizen science, ranging from improving data valid. Let's give her a warm welcome, please. Thank you. Please.
Thank you so much. Sorry, I didn't know you're going to read all that. Otherwise, I would have provided a shorter bio. So sorry. So hello, everyone. As he kindly introduced me, I'm a research associate at University of Applied Sciences and Arts, Western Switzerland, which I'm working on research projects mainly as a geodata scientist, but my main research focus is on citizen science projects because well, I believe citizens, they have great potentials in making really interesting contributions to scientific research. However, citizen science projects, they come with their own set of challenges, which we will explore today. But maybe before that, I just ask you a quick question, like how many of you are familiar with the concept of citizen science? You can raise your hands. Okay, good. Well, we will see together a little brief history of citizen science, so to make it more clear for the ones that are not familiar with it. Well, oops. Okay. Well, before 19th century, actually, the contribution to science was not considered as a profession. So people were contributing to science mainly as a hobby or like a self-funded project, and they were not necessarily considering themselves as professional scientists. And as we go further to the... Okay, oops, sorry. Okay. To the beginning of 19th century, more and more members of the public were making contributions to research. And this was the rise of the amateur naturalists, that there were many people that they were making contributions. For instance, the famous Christmas bird count project, that they were amateur ornithologists, that they were making counts of bird species. But there were also many other cases that people were collecting, for instance, observations of meteorological data. As we go further to the late 20th century, this was the time that citizen science introduced independently by a sociologist, British sociologist Alan Irwin, and American ornithologist Rick Boney. That Boney in particular, he defined citizen science as the contribution of the public in scientific research. And he actually emphasized that for the public to understand about scientific procedure, it is important that they actually make contributions to science. So he also mentioned that citizen science could be defined as public understanding of science. And finally, as we go to the early 21st century, is the time that we entered the digital age of citizen science. This was also the time that Web 2 was introduced, so it was the rise of many online platforms for user-generated contents. And this was also the time that there were many online platforms introduced for public participation. And now there are citizen science projects in different areas, in different kinds of contribution. The majority of citizen science projects are involved in environmental data collection, for instance, the famous eBird project or iNaturalist, but they are also in different fields like astronomy, even medicine, and the type of contribution could be also different. For instance, there could be simply data collection, or it could be like volunteers offering their computing power for scientists to make complex simulations, or it could be towards gamified applications, and even citizens together with researchers, they can collaborate to define new policies so that researchers and the local communities, they can collaborate together and mainly towards defining new environmental policies. As we go further and with the new technological advancements, and also the new functionalities of mobile phones and smartphones, even the affordable price of smartphones, this resulted in an increase in the number of citizen science applications. If we search the word citizen science, there are hundreds of different citizen science applications in different fields. And even this impacted the number of publications in this area, that since 2015, this was a significant increase in the number of citizen science publications. However, not all the citizen science projects, they are successful as they come with their own set of challenges that they need to be addressed. Well, among these challenges, there are two main challenges that they are particularly very important to be taken into account. The first challenge is the challenge of motivation. So the question is how we are going to engage people, the public, to initiate contributing to a project, and how we are going to sustain their participation, because this is not only the question of starting contribution, but also how they would keep contributing to the project. So we did a literature review to see, to identify different motivational factors in different citizen science projects, and we tried to categorize the different motivations based on the type of contribution and also based on the type of motivation, if it was mainly for initial engagement or if it was for sustaining participation. So we categorized the motivations to primary and secondary motivation. And there were different motivational factors that they were extracted, but for instance, some of motivations like to enjoy, to have fun, or to be connected with the nature, or to interact with like-minded people. There were motivations that were mentioned that they were effective in initiating participation, but there were motivations like receiving feedback and being updated about the project result that they were mentioned as motivations for sustaining participation. Well, the next challenge is the challenge of data validation and data quality, as Mir also mentioned in his presentation about crowdsourced data. Well, the thing is that citizen science data is coming from diverse group of communities with different social demographic backgrounds, different expertise, and so on. So the data needs to be validated before being used in other scientific analysis. And traditionally, this data validation was done mainly by expert verification, but as we saw that the number of citizen science projects increasing, and this results also this huge amount of data, and relying only on expert verification could be complicated because it could be time expensive. Also, it can be really complex to invite experts to make validation of the data. So this is another challenge that we need to take into account when we're dealing with citizen science projects. So back to the question of the main title is that how technological advancements could actually help us addressing, or maybe not, some of these challenges. First thing that I want to mention is augmented reality. That is not necessarily a new technological advancement, but it's used in different domains, especially recently in education, even for instance in furniture shopping, it's been increased a lot. Also, now there is AR view in Google Maps that it simplifies wayfinding. But also another use of AI is in motivating people to make contributions. For instance, I want to mention the case of OpenStreetMap, but most of you probably know the game Pokemon Go, that the in-game map is OSM, And many Pokemon players, actually, they made a lot of contributions to enhance the in-game map, because of course they are really serious players, and sometimes even they made more contributions than the regular OSM contributors themselves. So this showed that this AR application in Pokemon Go could be a way to increase motivation of people to make contributions. So we used this idea in one of our projects that is called Biosynthia. Sorry, could you please play the video? So we use the idea of AR integration in our Biosynthia project. Well, Biosynthia is a project that we developed with the idea of connecting children with the nature, and also to understand how they can use the AR view if they're more comfortable to find their way through an AR view or through a 2D map. And in this project, we had like different biodiversity points of interest, but here mainly on plant species. That these biodiversity points of interest, they were distributed as virtual icons that the student needed to walk in the nature and find the species in the nature. And as the student was getting closer to the species, the icon was getting bigger. So you'll see that, now, for instance, you see that the icon gets bigger, and even the student could tap on the screen, and there were indicators on how far you are from the species. So this was another indicator for them to look for the species. And as they were getting close enough to the species in the real nature, the color inside of the icon was getting full color. And then at that time, I wait 2 more seconds so that the student finds the species. Voila. Okay, so now the student found the species. So at this time, the student can tap on the screen, page opens with informations of this tree, and they can check the tree in the nature, compare with this information, and the idea is to help them to learn about the species while using this application. The thing is that what we realized is that the idea was to connect the students with the nature, but what we realized was that the majority of the time, the students were looking at the screen than looking around themselves. Sometimes even they were like going to have accidents with trees because they were all the time focused on the screen. So this was one thing. Another thing was that what we noticed, some of the students were actually seeing this application like the Pokemon Go game. So they were more interested to find more and more species than actually learning about it. So when they were finding it, they were okay, going and passing to the next one and not really focusing on learning and reading all this information. They were even making sometimes competitions among themselves, like who would find more and more species. So we noticed that this was not super effective in actually connecting them with the nature. And another thing that we realized is that most of them, they were using the AR view to locate themselves and to find the species and not the 2D map. And even the ones that they were starting to find the species through the 2D map, they were switching shortly to the AR view. And my colleague, he took the idea of Biosynthia and he actually tried to enhance it. Maybe, could you please?
L'érable à feuilles d'aubier ou érable
So
d'Italie est
this
natif
time,
d'Europe.
he actually tried
Il
to
pousse en
add an
moyenne
audio
altitude et est très robuste,
that
supportant
as
des températures
the user
jusqu'à
is
-25.
passing through the nature, there are also information about the species. So this way, there's not a written information, but actually is an audio that they can hear and learn while
L'érable
walking.
Negundo a été introduit
Also,
en
he
Europe
used eye
pour
tracker
agrémenter les espaces
to
verts.
see how
Elle est
much
devenue
time
une plante
person is
envahissante car elle
focused
forme un couvert
on
dense qui empêche la
the
croissance
screen and
d'autres
how much
espèces.
time looking at the nature.
Cela conduit à une banalisation des milieux qui est une menace pour
And
la biodiversité.
he got similar information that most of the time, 70% of the time, they were focused on the screen than on the
Elle
nature.
grandit très vite et elle supporte des conditions
So
difficiles.
what he did
Ces feuilles
as a
persistantes
second
ne
experiment,
tombent pas en automne.
it was to add a verbal
Ces fruits
nudge
ne sont pas
to
comestibles.
the user that
Le
as
pollen
they
de ces
are
fleurs est
too much
allergisant
focused on
et
the
le
screen,
contact avec ces feuilles
it
provoque
tells
des
them,
manchas
okay, look at the
irritations
tree.
des yeux
So
et des
they
voies
change the
respiratoires.
focus and they look at the nature rather than too much focusing on the screen. So this was, while this was effective to make the user look at the screen, more at the nature most of the time, but it has another drawbacks because after the survey that they did with a group of users that they were being receiving this verbal nudge and a group of users that they were doing the first experiment was that the verbal nudge was effective in looking more at the nature, but not more learning about biodiversity. So this was like, this was the positive points and the negative parts as well. So it comes with its own cost. So we realized that yes, it can increase motivation. It could be effective, for instance, in this experiment to learn about biodiversity, but it comes with this drawback that no, we are not really connecting them with the nature. It's still the screen. So another technological advancements, which of course is impacting almost every domain nowadays, is AI, which of course is obvious because AI and particular machine learning, deep learning, they come with their own set of capabilities, such as identifying patterns, anomaly detection, recommendation systems, understanding human language, even sometimes better than human themselves. So this is great, and it's understandable that why AI is entering a lot of domains. But the thing is that artificial intelligence and AI models, in order to work well, they have one main challenge is to have like large amounts of labeled data and to have large amounts of high quality labeled data, not only labeled data, because we are all familiar with the expression garbage in, garbage out. So this is actually one big challenge for training machine learning algorithms. One solution to that is again to bring citizens. So one way is, for instance, to collect labeled data is through passive approaches like the image recapture, where most of you have seen this, that it asks you a question like identify buses in the set of images, for instance, and then you are actually labeling data and providing labeled data for algorithms to be trained. However, there could be also active ways of collecting this labeled data, such as through citizen science projects, where there are citizen scientists that they label data voluntarily to be used in algorithms, to train algorithms, such as, for instance, in camera trap projects, that there are images of species that citizens need to, for instance, label the species counts in the image, or they need to identify specific species in the image, and so on. But this is like the help that citizens provide for the algorithms. What is the benefit for citizen science or citizen scientists themselves? That's the question to know how AI can be integrated in citizen science projects. So we thought of different ways that AI could be integrated from different phases of citizen science projects, from engagement and sustaining participation, for instance, by providing feedback to the citizens specific to their contribution, or it could be helping simplifying data collection, for instance, in species data collection by automatically recognizing the species name from the species image, so helping citizens to simplify data collection tasks. Or it could help also in data validation part, for instance, as I mentioned, expert data validation could be very complex if you're dealing with big data. And AI algorithms could help us to simplify this data validation by automatically filtering the data and passing only some flagged filtered contributions to expert for verification, so reducing the number of data that needs to be validated by experts. So the thing is that, maybe before going to the slide, is that AI integration could sometimes be appreciated by citizen scientists, but this is not all the time. So it could be like both ways. I present you two case studies. One is the Snapshot project that is developed by my colleagues from the Institute of Territorial Engineering and Media Engineering Institute. Well, I was trying to find the photo of my colleague Nicola, but that's the best I could find, so that's Nicola. Well, Snapshot is a project with the goal of creating a virtual globe of history by inviting volunteers to georeference historical images on a virtual globe and in 3D dimension. Well, there is a database available in Switzerland with hundreds and millions of historical images that citizens are contributed to georeferencing these images. Snapshot is actually a very successful project. It initiated in 2017, and so far there are more than 1,200 participants with more than almost 280,000 georeferenced images. And there are some of the participants that they are actually super active. So actually my colleague, Nicola, he developed an algorithm to automatically georeference images. And the idea was that the algorithm can georeference images and citizens can actually verify the georeferenced images to either say, okay, this is correctly georeferenced or no, or to improve the georeferenced images, the images that are automatically georeferenced. And this idea was presented to the citizens, to the participants of Snapshot, and it was not at all appreciated because they were saying that for them, the reason to contribute is the fun that they are having with georeferencing all these historical images. And they were participants that they were more than 60 years old, that they were super active, and this was really like an activity for them that they were enjoying. And this was not at all appreciated by them. So this idea was not integrated in Snapshot project, and now volunteers continue this manual georeferencing of the images. However, sometimes in other case studies, the integration of AI could be positive in citizen science projects. For instance, this is a case of a project that I developed that is called Biosense, with the idea of inviting citizens to collect biodiversity observations while in the same time providing them real-time feedback and the feedback that are specific to their contribution. So we provided them feedback in 3 dimensions: the thematic dimension to verify if the species image corresponds with the right species type, the temporal dimension to verify if the species falls within the observation date falls within the species visibility period, and finally the spatial dimension that we were checking the probability of observing the species in a given location. For the spatial dimension, I trained species distribution models for 100 bird species in Switzerland. That later, these models, I trained the models using eBird data. The data were already validated by experts. And these trained models were then used to validate new observations added by the participants. So in such a way that each time an observation was added to my Biosense platform, the environmental variables around the location of the observations was extracted in real time, such as average NDVI, average elevation, land cover classes, and so on. And these information were then passed to the API that I developed based on the saved trained models. And the model was taking these environmental variables and returning the probability of observing the species in that given location. And then this probability was then returned to the participant in the form of a real-time feedback with additional information of where are the other areas is more probable to observe the species. So basically, this is how the real-time feedback works for the spatial dimension. And also we provided like real-time suggestion of what are the possible species that could be observed in a given location. And we did a survey with the participants of the first test that we did, and most of the participants, they mentioned that the feedback they received, it was positive for them, and it was a kind of increasing their motivation to continue contribution, because in a way, while making contribution, they were also learning about the species, like where are the possible areas this species is going to be observed, the visibility period of the species, and so on. So this was another case study that AI integration was actually positive, had positive results in citizen science project. So looking at these two case studies, we see that so there are like benefits, but also challenges of AI integration in citizen science. And we were trying to have some categorizations of the benefits and challenges. For instance, for engagement, we saw that AI could be a positive way to increase motivation and to sustain participation. However, as I mentioned in the case of Snapshot, it was a way to demotivate participants, and sometimes too much task automation would result in making citizens not willing to continue their contribution to a project. Then for data quality, it could help in simplifying data validation and helping improve data quality even through the feedback that participants would learn over time and provide higher quality data. But it could also result in misvalidation of the data. For instance, if the models are trained on a set of data that are not applicable for validating new observations, this could result in biased validation. Or if the data are trained on a specific region or on a specific context, and we use those models to validate new observations, this could be, again, another way to make, to mislead the validation of the data. And of course, as Christoph mentioned, there are legal, ethical aspects that are critical to be considered, especially when we are working with citizens' data. I mean, there could be positive parts, like that the AI integration could be helpful in filtering, for instance, some sensitive information, but there are a lot of risks of legal and ethical aspects, such as data misuse, deep fakes. Now, there could be images generated that are fakes, and even an expert could not distinguish between the real, for instance, image of species and the fake image. So this is a big challenge in citizen science projects. And then, of course, transparency, and we know the black box nature of AI, and then transparency is another challenge, that when we are working with citizen data, we need to be clear enough how their data is going to be used to train models. Even if we are sending their data, if they're contributing to a project and their data is going to be sent to a third-party model, this needs to be absolutely clarified in the project, and they need to know how their data is going to be sent, how data is going to be used, and then thus we need to be fully transparent with the citizens. And, well, having said that, then it's important to have a kind of framework, a roadmap for the future, like how then we address these challenges, how we are going to go further with all these benefits, but also risks and challenges. The first thing is that it is important to have, to define benchmarks and standards, taking into account successful cases of AI integration in citizen science projects, but also cases that it was not successful, to define standard frameworks. And also it's important to consider that this AI integration should not result in excluding a certain group of community. So this is another factor that we need to take into account when integrating AI. And also, the thing is that, as I mentioned at the beginning, citizen science defines as public understanding of science. And the goal is that AI integration enhances citizens' capabilities, not replacing them. So if this AI integration is going to replace the role of humans, this is going to be a fail. And this is another thing that we need to take into account when integrating AI in these projects, or even in other technologies. Again, we need to have defined ethical and legal frameworks. This could be inspired by existing frameworks, but I believe that we need to have like really specific ethical frameworks for the integration of AI in citizen science and even VGI projects. And finally, again, Christoph mentioned this morning the environmental sustainability that it's important to take into account. Citizen science initially started without any application, without any mobile phone. So the goal, again, is to involve citizens in scientific projects. And if the AI integration is going to have more negative impacts on the environment than what we are going to have with the project itself, then is it really worth it, this integration or not? So this is an important element to take into account when building this roadmap for the future. And okay, I'm going to finish in 2 more slides. I just wanted to mention this project that got recently accepted and funded by Swiss National Science Foundation. The goal of this project is to increase public awareness about the spread of invasive plant species in Switzerland. And we are going to work with, we haven't started yet, so we don't have any results or anything, but the goal is to work with, the target audience is to work with high school students, to go with them in the field to observe the invasive plant species, and if possible, sometimes to eradicate the species, using the species distribution models to identify the high probable zones to observe the species. But why I'm mentioning this project here is that one interesting thing that we are going to do in this project is that we are going to develop a very basic game, a paper-based game with the student, that they learn about the concept of species distribution modeling. So we are going to give them like different paper maps, like temperature, elevation, and so on. That could be transparent maps that they can even post on top of each other. And we ask them, okay, like how would you see these species spread in the nature given these criteria? For instance, temperature more than 30 degrees, elevation, this criteria, and so on. And then the student would draw how the species would actually spread in the nature. So the idea is maybe to address also this black box effect of AI, that to help them understand how these species distribution models are produced, and not just giving them the model, going with the application in the field and collect data, because they are not sensors. They are there to understand about science and the scientific procedure. And voila, to wrap up. So the thing is that citizens are the core of citizen science projects. So if any technical integration is going to be done in citizen science project, we need to ensure that it's not going to replace the role of citizens, but to enhance their abilities, their capabilities. As I mentioned, we need to have like a framework that illustrates a responsible technology integration in citizen science projects. And finally, it's important to know that democratization of science does not mean to give like boring tasks to AI to automate those tasks and then let the other tasks for citizens to do. The thing is that some tasks that might seem boring for a group of participants, it could be interesting for another group. So it's important to actually understand the desire of citizens and not just deciding for them. And yeah, if they're going to automate some tasks, we need to be sure that those tasks are going to be replaced by new tasks for citizens, and their contribution needs to be valued. So that's all from me. Thank you so much for your attention.
Thank you, Dr. Mariam. We'll now pass to the question section. We only have time for a couple of questions. I am really sorry to announce that, but if you have any question, you can raise your hand so my partners can go to your place.
Thank you, Mariam. It was very interesting, especially the application that you showed that engaged students, younger, to learn more.
Yeah, sorry, could you please speak without the microphone because your voice is breaking, so maybe it would be... Of course, like all the code are open source on GitHub. I can share it with you. I think it will be very easy to reproduce these results. Of course, the biodiversity points of interest are local for the study area that we worked on, but this could be easily replaced by new data points, and then the code could be regenerated for another area. But yeah, of course, I will share this with you. So the application, the bioscientific application, I'm not sure if the server is running at the moment, but as I said, the code is available, but the work of my colleague, the one with eye tracker, that is functioning at the moment, the server. So you can even try the application. So thank you.
So, have you figured out what is the motivation? The motivation?
Sorry, again, could you please maybe talk without the microphone because the voice is breaking and I cannot hear you very well.
Okay.
Yeah, thank you. Yes, that's a very good question. Yes, for one case study, we actually categorized the motivations based on age groups. What we noticed was that the motivation for instance, for the age groups was to walk with like-minded people and to, for instance, walk in the nature. Well, it was a biodiversity project again, so maybe my answer could be biased to biodiversity, but anyway. So this was the motivation for the older group of participants. But for a younger group, like one thing, it was like for learning about science and scientific procedure, but also like having fun. It was another motivation that was mentioned for the younger group of participants. But to mention that this was like really, we did not really observe like extreme differences in motivation. So when we plot the box plots, there were like differences, but not really like significant differences between different age groups. But yeah, that we observed.
Yeah, so thank you, Dr. Mariam. We would like to give you a little gift for your participation. Thank you. Thank you. Now,